In this video, we'll be looking how we can use computer algebra systems in the classroom to aid students' understanding and give them a greater degree of intuitive feel for difficult algebraic topics. We'll be looking at three different pieces of software: Microsoft Mathematics, which is free; the CAS element of GeoGebra, which is familiar to many of you; and Texas Instruments TI Nspire CAS, which is a paying piece of software but immensely powerful. Let's look at Microsoft Mathematics first. It's very, very easy to use, very intuitive. First of all, I'm going to enter an expression. When I press enter, you notice it gives me what I put in and what comes out, and it's simplified it. All three programs do the same thing. They'll simplify anything which can be simplified. Now that gives scope for teaching algebra further down the school. Collecting like terms, for instance. Why can that be simplified, but that doesn't? Further up the school, input that. The program outputs the other. Why has it done that? Ask your students. Here I've put in an expression, x squared plus 3 all squared. Okay, the input's the same as the output, but notice underneath it gives me several different options, and I'm going to choose to differentiate. Press enter, and there we are. If I take the original input, copy it, which is very simple, and then change the squared to a cubed outside the bracket, press enter again, we can compare with the first result. Now, doing this, we can get students to start to predict what happens when we differentiate certain kinds of function of a function. And then we can look at other different kinds of function of a function and get them to tell you in advance what they think the differential will be. GeoGebra has, since 2 or 3 years ago, had a CAS element of it. Very few people seem to know about it, fewer still seem to use it. Here's an example of how I would use it, or how I've used it, to teach differential calculus from the very first lesson. In the right hand graphics page, we've got the function y equals x squared. We've got a tangent. We can establish by discussion that the gradient on the tangent is the same as the gradient on the curve at any one particular point, and ask the students, as we move that point A around the curve, to notice any connection between the x coordinate and the gradient, and they will tell you that it's twice the x coordinate. Then we can talk a little bit about new terminology, introduce them to the idea of derivatives, differentiation, dy by dx notation, and so on. And then we can go into the left-hand pane, the CAS pane. We can check our first results, derivative of x squared is 2x. We can try the derivative of x cubed, 3x squared, and at this point I say to the students, okay, what do you think the derivative of x to the power 4 is? And they will tell you. And we can proceed on to that until finally, at the end of about 20 minutes, you can confidently put in and ask them what the derivative of a times x to the power n is going to be, and they will tell you. Texas TI Nspire CAS is more than just a CAS program. It's a lot of different functions, graphs, spreadsheets, all sorts of things in one rather super package, but you do have to pay for it. But what you get is very, very good. You can buy the PC software on its own, as you can see in front of you. You can buy this, which most people would call a calculator, Texas call a handheld, and that will do everything the PC version will do. you can buy a version, an app for your iPad. And all three platforms will quite happily talk to one another. It's easy to swap files between one and the other. Here's an example of a graph which displays exact coordinates, which is something no other graph plotting software can do, to my knowledge. Here's an example where I've split the screen into two. The right-hand pane has got two functions of x plotted, and in the left-hand page we're getting it to perform very basic calculations, including finding functions of functions and finding inverses of functions. I'm going to ask anybody who's interested in coming to the workshop to download Photomath onto their smartphone. You may or may not have heard of it, but what is almost certain is that most of your students know all about it. And one of the things we'll be looking at is discussing how we're going to meet the challenges which things like this and things still to be developed are going to face us as we move into the future. Anyway, here's a little, we'll just end up by looking at what Photomath can do, and let's think about how we can use it to our advantage.